Okay, there we go. It is 8 o'clock. I have no idea how it already is 8 o'clock. Okay, good morning, students. Welcome to Thursday morning, April 23rd. And yeah, a random corner. I literally lost track of time, and I figured a little more important to actually start the stream on time than to try to look up a random joke. If you have a suggestion, let me know in chat and then I'll put it up. I am taking all suggestions for the random corner today. Okay, so hopefully the test this week for pre-cal, or for both classes, hopefully the test went well. I haven't started grading any of them yet because it was due last night while I was asleep. It's really funny now that we've started this online school, how many of you turn in things between like 11:30 and midnight, which just goes to show high school kids. Fun. So high school pre-cal, we have a lecture for today, so you have your next lesson. We have probably... So I think what's happening with this unit is we're going to cover this assignment. We're going to have your homework over it. It's going to be due in a week, just like normal. But it's not going to be covered on your next exam, which honestly, it still should matter to you because your homework grades are so much more important than your test grades with this online school breakdown anyways. So definitely get it done correctly. But exam number 2 is not going to cover this unit we're going to talk about today. And the whole reason we're covering it is because it kind of ties in everything we've been doing this is kind of the culmination of everything that we were supposed to get to by this point in the year. I've had several years I've taught this class where this was the very last thing you teach, but we're going to do something else this year. Let's see. So we're going to cover that today. If you're following along and you want to make a little more sense of the values of the numbers that I'm looking up, I attached this Trig Chart thing. If you remember, there's a handful of you. I didn't make it mandatory during class, but there's a handful of you that filled this out already. So if you have a paper copy, great. But just have this open as we do our thing today, and some of the values I will look up make a little more sense. I mean, I'll put it up on the stream too, but just when you do your homework, you're going to want it. Let's see. Extra credit checkpoints. Let's see. I think you have one. You have one due tomorrow. So tomorrow's is basically going to be the last actual research portion of this that you do. So for those of you that are involved in this extra credit, you're going to be solving a math equation, looking up some math things, and I'll tell you all the instructions here. But that's the most math-centric portion of the thing. And then you're going to get to writing your paper, and we will do our presentations. You're almost to the end of the extra credit. Most groups have actually been keeping up with it pretty well. So, I mean, 10 groups here? I think we have 13 groups in dual credit, and it's going great. I'm glad so many of you are getting involved. Today's assignment is posted here. I just posted it, 7:36. So there's that. Other announcements, I'm trying to think. Let's see. What else is going on? If you haven't heard, we're not taking any final exams. So basically for me, after you take this second exam, you're going to be done. I don't know what their plan is for the end of the school year. Oh, it looks like I'm lagging. Hold on. There we go. Okay, I don't know what the school is planning for the end of the school year, but we'll see how it goes. All right, on to the lecture. Let me pull this up real quick on my side. Downloads. Close this out. Okay. So it's funny, ironically, you know how I teach the Lee College dual credit pre-cal along with the high school pre-cal, so that's why you always hear me say there's a difference between the two. My dual credit actually didn't get to this. before their exam. So y'all are going to learn something my dual credit class didn't. It's not a big deal. It doesn't take very much, but it's, you know, they didn't get this lecture, which is kind of funny to me. Okay. Alright, so solving trigonometric equations. This ties in all of the algebra that we did last semester along with just the definition of trig things that we've talked about this semester. So it's kind of a culmination of everything that we've been learning. So first things first, you have to know how to look up stuff on the trig chart. So if you remember, we started with the unit circle. So before we write, okay, actually, I can just Alt-Tab. So we've talked about where the unit circle comes from. We've been using it to death. We've used it over and over and over again. High school kids, y'all took a quiz on this and you can recite this from memory at this point. But the key here is that whenever you go to a certain angle, whenever you go to a given one that has a special thing with special coordinate points, then you can always look up the sine and cosine of that angle by just looking at either the x or y coordinate. So if I ask you something like sine of theta equals square root of 3 over 2, and I want to know what theta is, I'm asking you what happened to my equal sign? I'm asking you the question, well, on the unit circle, or based on my definitions of trig, at what angle values does sine equals square root of 3 over 2? Sine would be the y coordinate because of the y coordinate tells you the opposite side of that little reference triangle that we draw. So square root of 3 over 2, you see one, where's my mouse cursor? Right here for the y coordinate. So 60 degrees would be an answer. You also see one over here, so 120 would also be an answer. So 60 and 120. I don't see any others where the y coordinate is positive square root of 3 over 2. So your answers are 60 and 120, or pi over 3 and 2 pi over 3 for pre-AP. All right? So 60 and 120. Now, technically, if I asked you what are all possible answers to this question, then you would literally never stop, right? Because values are periodic. I could just spin around in a circle and add 360 to both of these, right? So 420 and 420 and 480, yeah. Those would also be answers. I could add 360 again, I could add 360 again. I can keep spinning in that circle over and over and over and over again. And you can get answers all the way to infinity. Now, a sneak peek of the stuff ahead that we're going to do. So notice how the instructions always say, just give me the answers between 0 and 360 degrees, or one rotation around the unit circle. All right? So that narrows down the field so you're not writing answers to infinity. All right, where is cosine equal to square root of 2 over 2? So cosine would be the x coordinate. So square root of 2 over 2, there it is. So you have an answer at 45 degrees, or pi over 4 for pre-AP. This is negative, so we don't want that. And then the other one, as we circle around, is at 315, or 7 pi over 4. So your two answers here in the range 0 to 360, your two answers here are going to be 45 degrees and 315 degrees. 45 degrees, 315 degrees. Now we get to the super annoying one, the tangent one, right? We always hate tangent. Where is tangent equal to square root of 3 over 3? The annoying part about using the unit circle for this, and the reason why I didn't post it on the post for this lecture, is because, well, tangent is not directly readable off of this. What you have to do is tangent is sine divided by cosine, or y divided by x. So you have to do a fraction divided by a fraction, and you would literally have to do it for every single point on the circle. That would be a lot of scratch work. So that's what the trig chart is for. The work is done for you already. So if you look at this, here's all your degrees, all your special spots on your unit circle from 0 to 360. All of them in radians, if you didn't know the radians. Regular, you won't need the radian column. And then here's sine. Here's all of the y coordinates. Here's cosine. Here's all of the x coordinates. And here's tangent. Here's all of the y's divided by all of the x's already ahead of time. So you don't have to do it over and over again. All right? So this is why we like the chart. So I'm even going to close out this unit circle. We're not going to need it anymore. The chart is the only thing you're going to need. So tangent. Where is tangent square root of 3 over 3? Well, I see one right here at 30 degrees. I see one right here at 210 degrees. So 30 and 210. If you're doing these problems correctly, this process of looking up one of those values on your trig chart should be one of the very last steps you do in the problem. So for the rest of this, for the entire rest of the lecture, all you're doing is just, there's going to be some numbers around the outside. We're going to use our algebra knowledge, because we did it all last semester. We're going to try to isolate the sine, cosine, or tangent. And we're not using cosecant, secant, cotangent. So sine, cosine, tangent, I'm going to find one of them, isolate it, look up the value on the trig chart, and then possibly do an answer after that. And remember, theoretically, there are more answers. I could keep going. I could add 360 to every single one of these and get more and more and more answers. And technically with tangent, I could just add 180, right? Because we did this graphing stuff already. So I could just keep adding 360 over and over and over again. So we say n because n could be any value. N is any integer. Cosine, I could add or subtract 360 over and over and over again. Tangent, I could add or subtract 180 over and over and over again to any of these answers. Because remember, the period of tangent is 180. Oh, I should write the little ends. So just keep that in mind as we get all of the answers from 0 to 360. Okay, let's go. First, I separated these into all the different ways that the algebra work could be arranged. So you'll see I have a slide for outside things, inside things, doing both. I tried to arrange it as nice as possible to make it follow your homework and to make it, you should be able to just use these directly as a reference. Okay. So solve the equation, and the instructions are going to be solve it between, give me every answer that exists between 0 and 360 degrees, or one rotation of your unit circle. Pre-AP, you're going to have to give the answers in radians. Really, that doesn't affect you that much until the end of this worksheet. But regular, use the degree column. Pre-AP, use the radian column. And here we go. So 4 sine theta plus 3 equals 1. Well, sine theta is what we want to solve for, so we can get to the point where we look up stuff on the trig chart. Oh, sorry, I just got a message. Private message. Okay. So, step 1, we would subtract the 3 over before we divide the 4, right? Normal algebra. So we've got 4 sine theta equals -2. Now we get to divide the 4 over. Oh wait, 4. I need a new stylus. This little thing, so this is what I've been using to write the whole time. This little rubber thing is so, like, it doesn't actually give you much. It gives you too much friction whenever you write. Ugh. I don't like it. Alright, sine theta equals -1/2. And notice how this now looks exactly like what we just did back here. Where is sine equal to -1/2 on the range 0 to 360? So we go to our chart, sine column right here, this third one. Hold on, let me get my mouse cursor. Right here, this one. And I want to find out every answer where sine is -1/2. So here's 210, and here's 330. So 210 and 330 are my answers. Oh, come on. I'm trying to do a little degree symbol. There we go. Okay. There we are. See? So, I mean, obviously this is the first one, and it's going to be the easiest one because there's not much work. But this is essentially what you're doing for the entire worksheet. The algebra gets a little worse, but the last step where you're just looking, the actual trig portion of this problem is you're looking stuff up on the chart. Okay. This is the only slide I have two problems because I needed to show you this happens sometimes. So right here what we would do is divide the -2. And so I have -2 equals cosine theta. But if you try to look up -2 in the cosine column, it's never there, right? Your x-coordinate never can hit -2 because your radius is literally 1. So, oh no, I've gotten a point where cosine is never equal to -2. This is just a no solution. No solutions do happen, and there is at least 1 or 2 no solutions on both versions of this homework. So when you see that particular problem, that's the reason why that's happening, is because that value, that trig function, literally can never hit that value. All right, checking for questions in chats. Nothing. All right, let's move on. What if you have a step on the inside? So notice how there's a plus 210 inside the parentheses, inside the cosine. This means we have to look up our solutions on the trig chart, and then we have to do a bunch of stuff to the answers. So cosine of theta plus 210 equals -√2/2. Well, the 210 is inside the cosine value, so cosine's already solved for. So that means I can go ahead and look up -√2/2 for cosine already. Where is cosine equal to -√2/2? Well, 135 and 225, right? So 135, 225. Except now this 210 is still here. Now notice how my next step is going to be to subtract 210 over to get theta by itself. But 135 minus 210, and you don't have to do that mental math, but you know it's negative, right? But the problem is asking you for solutions between 0 and 360. So whatever 135 minus 210 is, it's not going to be in that range, so it's not going to give you an answer. Here's the dilemma. Remember how I talked about things being periodic? There are more answers to this problem, right? Because the unit circle goes forever and ever and ever and ever. So I might, because I know I'm subtracting 210, wait, hold on. Camera's backwards. Yeah, because I'm subtracting 210, then I might have to look at some of the other answers that are past 360 that are not on my chart, because they're going to get subtracted and maybe fall back into the range 0 to 360. Does that make sense? So what is 135 plus 360? Because that should be the exact same spot on the unit circle, right? So 495. And then just to be safe, let's go ahead and do it to the 225 too, just in case that minus 210 is in our range. So what is that? So I have 585. Now these answers go on forever and ever and ever. I think we're pretty safe at this point. The next one would be like in the 700s, 800s. So now I subtract 210 from all of these answers, every single one, and just list the ones that are between 0 and 360. So 135 minus 210, it's negative like I expected. 225 minus 210 is 15. 495 minus 210 is 285. What about 585 minus 210? That's 375, which is really close, but it's not there. So For this problem, I had to look up the values, and then I had to subtract 210. The reason why the 285 is an answer is because I had to realize, oh, my trig chart's actually periodic. There's actually answers that go on forever and ever in both directions to infinity. I had to pull up one of the bigger ones that was out of range, because when I subtracted 210, it now became within range. So that's the trick for when you have numbers inside of your parentheses. Okay. Pre-AP, this is whenever it gets a little bit tricky and you might want to use your calculator to do all your fraction stuff, because these are all going to be fractions. So, you end up with 3 pi over 4 minus 7 pi over 12, or, something like that. Kevin, how do we do those values in radians? So if I were to do this exact same problem in radians, then instead of 210, you would have saw 7 pi over 6, and then you look up cosine negative square root of 2 over 2. And then instead of 135, you would have used 3 pi over 4 and 5 pi over 4. So you would have written out 3 pi over 4, 5 pi over 4, and then your period is now 2 pi every single time. Whoops. So back here, for you, it's going to be 2 pi n. 2 pi n, or pi n. So take your 3 pi over 4 and your 5 pi over 4. Add 2 pi to both of those, so that's what makes you have your list. Does that make sense? So you end up doing 3 pi over 4 plus 2 pi, 5 pi over 4 plus 2 pi, and that's fraction math, so you need to do the whole common denominator thing. And then you have to only give me the answers between 0 and 2 pi, and then so you have to compare fractions to the value 2 pi and see if it's too big or not. Just my best piece of advice for pre-AP students who are bothered by the radian part of the problem, which I realize that is going to be some people. Just remember, don't actually type the pi into your calculator. Just make your fraction into a decimal and just compare the decimal to the value 2 to see if it's bigger than 2 or smaller than 2. That should give you some help there. If you're comfortable enough with fractions, just take a look at the fraction, reduce, and see if the least common denominator gives you anything over 2 or not. But okay. All right, what about if you have steps for both? All right, so negative 4 equals 4 tangent theta plus 225. So I've got two things to do. I've got to divide the 4 out from in front of the tangent, look up on the trig chart, and then subtract 225. Okay. So first step, divide the 4. So I've got negative 1 equals tangent theta plus 225, or 5 pi over 4 for radians. So my tangent is solved for. I look up where tangent is equal to negative 1. So where is tangent equal to negative 1? So go down your tangent column. Here's my first one, 135, 315. Oh, I didn't actually leave room for my plus 225. Whoa. Wait, subtitles. No, I don't want subtitles. Okay, so the two values that I found on my trig chart for tangent being negative 1 is 135 and 315. So, and again, I looked that up using my trig chart. Here's the column, 135, 315, right there. Now remember, tangent's period is only 180. Also, if you'll notice, 135 plus 180 is 315. So I've got other values that keep going. So just keep adding 180 to either of these, and you get more answers. You get, so, 4 pi n. Okay, so you actually have 495 as another one here. where you've got 675. I think that's big enough. Okay, so just add 180 over and over again. So now I subtract the 225 from both sides. So I'm subtracting 225 from all of these, and I'm just giving the solutions that are between 0 and 360. So 135 minus 225, that's going to be negative 90. That's a no-go. 315 minus 225, that's 90. That's fine. 495 minus 225 is 275. And then 675 minus 225 is 300. Wait, why did I put 5? Sorry. 495 minus 225 is 270, not 275. Okay. And then 675 minus 225 would be 350, which does fit, right? Oh, wait, no, that's 450. I lied. That doesn't fit. I'm done. Oh, what a morning, eh? All right. 450 is bigger than 360. I don't know if you knew that. Fun fact, 6 minus 2 is 4, not 3. Okay. By the way, this is something that a lot of students forget, is that tangent actually only has a 180 period, not a 360 period. So just be careful whenever you're doing that, just for tangent problems. Okay. All right. Another thing we did with algebra solutions for polynomials and for things is to factor to solve. So you're going to have to factor a trig function, but what's going to end up happening is you just end up doing two problems at once. So notice how this one I looked up tangent, this one I looked up cosine, this one I looked up sine, whatever. Here I'm going to end up factoring something out, and then you're just going to look up two different things on your trig chart and then just combine all your answers together in one list. So I'll show you what I mean. So step one here, if you see multiple trig functions, like I see cosine, cosine, tangent, so I see all those, is a good indication that you're going to have to factor something. So step one, in order to factor, I need all of my common factors. I need everything on the same side of the equal sign. So I'm going to add the 3 cosine over to the left. So I end up with square root of 3 cosine tangent plus 3 cosine equals 0. So notice how I only have two terms. I have square root of 3 cosine tangent plus 3 cosine. So if I put a giant parentheses around the whole thing, term 1 and term 2 both have a cosine there, right? So I can factor the cosine away. And I'm left with, parentheses, square root of 3 tangent plus 3 equals 0. So just like with algebra, whenever you take a thing and you factor something away, once you create a something with a parentheses or a parentheses with a parentheses, and you set it equal to 0, you set each of them equal to 0 separately, and you come up with two sets of answers. Just like if you had like x squared plus x equals 5, factor the x, you get the idea. So here, I can either just set cosine equal to 0, and the whole thing becomes 0, or I can just set that equal to 0, and the whole thing becomes 0. So I end up with two sets of solutions. So I'm just going to do two different, lookups of the trig chart. So on the one hand, I've got cosine theta equals 0. On the other hand, I have square root of 3 tangent plus 3 equals 0. Oh my goodness, that's awful. All right, hold on. I tried to make it look nicer, and I just made it way worse. There we go. So for cosine theta equals 0, I can already look that up. So I go to my cosine column. So it's 0 at 90 and 0 at 270. I'm not doing anything weird to the theta afterwards, so I don't have to do the whole plus 360 thing because I'm not subtracting or dividing anything. And now go to the tangent half. I would subtract the 3. I've got square root of 3 tangent equals negative 3. Divide the square root of 3 over. And you've got tangent theta equals... Now, you do have to rationalize this, right? And the reason why you're not going to find this on the trig chart is because the square root's on the bottom. So you've got negative 3 over square root of 3. I've got to do square root of 3 over square root of 3. Oh boy, my kids are having a fight out there. So tangent equals negative 3 square root of 3 over 3, which just becomes negative square root of 3. So now this is what's going to show up on my trig chart. And it is all behind my head, so let me move that real quick. Whoop. There we are. Okay, so tangent theta equals negative square root of 3. So I look up negative square root of 3 on my tangent column. So it's at 120 and 300. Right? 120, 300. So for the cosine part of the problem, I had 90 and 270. For the tangent part of the problem, I had 120 and 300. And then so your answer is all 4 of those answers. So, I mean, you can just do this and it'll be fine. But all 4 of those are your solution to this problem. Any of those will give you this equation to be true. Okay. All right. Let me move my face back into my box here. Whee! Oh, wait. Get the pixels just right. There we go. Oh no, it's on. Oh, whatever. Okay. All right, regular. We're about to be on our last slide per AP. You've got 2 more. So sometimes the thing you have to factor is a quadratic. And again, it's going to give you 2 different things, 2 different sets of things to solve. You're going to look up 2 things on the trig chart. For this one's actually, they're both going to be sine, so it's okay. All right, step 1, as with any quadratic in algebra, you can't do any factoring and solving until you have one side equal to 0. So step 1, add the 4 over to the left. So now the right-hand side of the equation of the equal sign is going to be 0. So you've got 2 sine squared minus sine minus 1. So that's a quadratic, right? 2x squared minus x minus 1, same thing. So you can do slide and divide, or you can guess and check this one. This is going to factor into 2 separate things. So I know one of them will be 2 sine. I know one of them will be 1 sine. I know the numbers are going to be 1 because it's 1 times 1 equals 1. That's the only thing that works. And it's negative. So one of them has to be negative. One of them has to be positive. So I'm going to put the negative over here and the positive over here. Because that way my FOIL, it gets a sum of a negative 1 on the inside. If you don't know how to do just guessing and checking or just observing signs, it just takes slide and divide. I know slide and divide seems kind of pointless with 2 and 1, but if you don't understand how to just read the signs, you should do that. So slide and divide here if you need to. But here's my 2 parentheses. So I've got 2 different equations I can set equal to 0. So I've got 2 sine plus 1 equals 0, and sine minus 1 equals 0. So here, I'm going to subtract the 1 and divide the 2. Let's go ahead and write everything. Divide the 2. Oh, not negative 2, 2. Get out of here. Alright, so sine theta equals negative 1/2. And then here I'm going to add the 1, and that's it. So sine equals 1. So notice how they're both sine, so I'm going to be using the same column for both of these solutions. But where is sine equal to negative 1/2? Where is sine equal to positive 1? So let's just do it separately so we don't get too confused. So let's just look up sine being -1/2 first. So sine is -1/2 back here at 210 and at 330. And then sine is equal to 1 at 90 should be the only place. Alright, there's only one place on the unit circle where the y-coordinate's 1. So you got 3 solutions to this problem, 90, 210, and 330. Alright, before we get to the very end, last slide, I'm going to do my daily Twitch drop. So I am going to use handy dandy random number generator. I really wish I could just use the bot for this. There's like a Twitch bot you can use for drops and things like that, but I can't enable it until I give Twitch all of my personal info, which I'm not going to do. Alright, we get to do it the old-fashioned way. How many people do I have logged in right now? I see there are 6 of you. Number 5. Oh, you're ineligible because you have already won. Let's see. Number 1. Alright, message you real quick. Okay, I messaged you, mystery winner. And please respond so I actually know you're awake. And we will get back to this problem. Actually, no, we're done with regular slides. Sorry. Okay, pre-AP, those of you sticking around, let's do this last one. Okay, so if you notice, you see squareds, so you're going to be factoring, just like we did on this last one. Except I have a sine squared and a cosine squared. So how do I factor either sine or cosine away? And you can try a bunch of combinations here if you want to, but you can't actually you can't separate this into something. So here, let me show you. Okay, so add the 2 over. Add the 2 over. You've got sine squared minus cosine squared minus 3 sine plus 2 equals 0. I've got 2 different square terms that don't currently combine, and it's not yet a Pythagorean identity. Sine squared minus cosine squared is not an identity. So what do I do here? How do I actually factor anything away? How do I FOIL? How do I do anything like that? The answer is you can't. But luckily, we know Pythagorean identities. So the most important one you're going to need is this one, the one I always star. Because if you think about the unit circle, right, any x coordinates, if you do Pythagorean theorem on any part of the unit circle, it's always x squared plus y squared equals 1 squared, which is 1. Right, and that's the reason why this identity was true. So here's our magic identity. Well, what if, you notice how there's 2 sines in the problem and 1 cosine in the problem. So what if I could just magically change cosine squared into sine squared? Well, you can, because take this equation, subtract the sine squared over, cosine squared equals 1 minus sine squared, and guess what? That gives me something to substitute into there. Got it? So I can substitute in and change this problem entirely into a sine problem. So I just have to distribute the negative and combine a couple of like terms, and this will now become a problem exactly like before. Okay. So distribute that negative out. Here, I'll go ahead and write out this line right here. Sine minus 1 plus sine squared minus 3 sine plus 2. And then you got the sine squares that combine, and you've got the negative 1 plus 2 that combines. So, oh, hold on. You know what I'm going to do? I'm actually going to move this work way up top because I want this blank space. Hold on. Get out of here. Okay, I'm just going to write it. I know it's under the overlay, but I want some more room. Oh my goodness. Do y'all hear my kids screaming out there? It's insane. A fun screaming. I think they're done fighting, but kids will be kids. Oh, come on. There. Anytime I'm near the edge of the screen and I swipe from right to left, it pulls that little menu out. So, okay, so let's combine like terms here. I end up with 2 sine squared minus 3 sine. And now I have negative 1 plus 2, so plus 1. All right. All right. Looks like we may just have a lurker. So I am going to re-roll a new winner here in a minute. Okay, so factor this out. It's a quadratic. There we are. So the leading term is 2 sine squared. So you know one of these has to be 2 sine, and the other one just has to be sine. The last coefficient is just 1, or the last term, not coefficient, sorry. So 1 and 1. And the middle term's negative and the last term's positive, so you know both of these have to be negative. So you just use a lot of deduction here to figure out what your terms and what your signs are. So if you FOIL this back out, you should get the term up top. So set each of them equal to 0 separately. So sine of theta can equal 1/2, or sine of theta can equal 1. So where is sine equal to 1/2? Well, go down the sine column. So we've got, and this is pre-AP, so I'm going to bother with degrees. So sine of 1/2 at pi over 6 and at 5 pi over 6. And then sine's equal to 1 at 90 degrees. I already remember that, so pi over 2. See, right there. Alright, we're going to roll another winner here. Ah, lucky student number 3. Whoops. Alrighty. Okay, so that is the lecture that should get you through every set of problems that I assign to you on the worksheet. As always, remember, head to your classwork, PDF, use your appropriate PDF, show me all your relevant work. And guys, I'm sad that I have to keep announcing this every single time I assign you a homework, but please actually show me the work, because remember, this isn't a mistake. I provide the answer key. So if you literally just turn in a paper where you wrote the answers with 0 work, you're getting a 0 on this assignment. The whole point is to use the key to check your work. So you need work to check. All right? So get that done, turn that in. We're not going to have a final exam, but we are going to have a second exam, and we're going to tie this back into what we're going to do later. So please actually get this done on time. test grades, I have no idea when we're going to actually be done, or I'm actually going to be done grading tests. I actually have several meetings to go to today, and then probably I'm going to try really hard to get these done by the end of the day tomorrow. If they don't get put in on time, I apologize, but I mean, I'm going to start today. We'll see how far I get, and then tests, let's say, definitely by Monday at the latest. Does that make sense? Okay. And also, yeah, pre-AP, I know y'all are waiting for grades, but dual credit, they only take so many tests per semester, and I got to grade theirs first, so that's usually where the delay comes in. So dual credit and pre-AP, anyone from dual credit that's actually watching this video, I will be getting to y'all's tests very soon. I probably will be done with tests late tomorrow, if not on Monday. Okay? All right. That is all I have for y'all today. I will post this video and this PDF of my annotated work momentarily, and y'all have an awesome day. I will see y'all tomorrow.